All right, tornadoes. Today we're going to talk about the deadliest of tornadoes and a look at the deadliest list from the US and the world. We're going to talk tornado characteristics and some things you can kind of notice about tornadoes and things we learned from studying them. We'll talk about how tornadoes form, the damage they do, and the strength that goes along with that. That's called intensity. And then we'll study some of the tornado outbreaks that have happened out there and how you can keep yourself safe during a tornado. We begin with the deadliest. What was the deadliest tornado in U.S. history? And the answer is the Tri-State tornado. On March 18th, 1925, the Tri-State tornado ripped through the southern part of Missouri, Illinois, and Indiana. And it did terrible damage to 23 towns. It killed almost 700 people, 689 people. And it took a path through those three states that was 353 kilometers long. The path of the damage path from the tornado was almost a mile wide, and the wind speeds were estimated at 318 miles an hour. So this was the Tri-State tornado, the deadliest in U.S. history. In fact, if you look at a list of the top 10 deadliest in U.S. history, the Tri-State tornado there is the first one on the list, 1925, March 18th. The second one being the Natchez, Missouri Natchez, Mississippi tornado of May 7th, 1840, and that one killed 317 people. There was one in St. Louis that killed 255 people. So tornadoes can occur anywhere, anytime, even in large cities. And the most recent one on the top 10 deadliest list would be Joplin, Missouri, where 161 people died on May 22nd, 2011. That was a pretty terrible event. Top 10 deadliest in the world are listed here, noting that the Tri-State tornado is number 2 on the list. The number 1 tornado on the list would be a tornado that occurred in Bangladesh. Bangladesh there is just east of India, and so it's very densely populated. So a tornado through here was kind of a tornado in a very bad area. It killed 1,300 people on April of 1989. North, central, and northeastern India are situated very much like the central part of the United States, where they have warm, moist air wafting in, and cold fronts frequently coming through, plowing the warm, moist air upward. So, believe it or not, there's a lot of tornadoes that occur in Bangladesh because of that. To give you an idea of where the tornado deaths occur in the U.S., is this map. This is a map of tornadoes from 1950 to 2006, so essentially the second part of the last century. And we see Texas overall has the most deaths, but there are a lot of deaths there in Arkansas, Mississippi, Alabama, all parts of the South, really, Tennessee. Of course, Illinois has 202 there. A lot of deaths in Indiana and Michigan as well. So they're pretty well distributed all over the central part of the U.S. In fact, the central part of the U.S. is known as Tornado Alley. 70% of all of Earth's tornadoes occur in the central part of the United States. In the 1900s alone, there were almost 15,000 deaths from tornadoes in the U.S. On average, then, that's about 60 tornado deaths per year, and you can see this graphic showing the frequency of killer tornadoes over the last half of the last century, noting that the most deadliest tornadoes that occur there in the center of the South, right there, Arkansas, Tennessee, northern Alabama, and Mississippi, right in that zone down there. Let's talk tornado characteristics. First of all, just to define a tornado, it is a tightly rotating updraft produced by a large thunderstorm. And typically and most often, tornadoes form in supercell thunderstorms, which you see pictured here. You can see this beautiful large cumulonimbus cloud rotating in the atmosphere, being fed by warm, moist air, creating a very thick amount of condensed water droplets everywhere. Upper level winds are tilting the storm to the right, as we see pictured here, and the updraft then would be in the toward the rear part of the storm, where you see it tightened into a spiral to form that tornado. Tornadoes are the highest wind speeds of any weather phenomenon. They're more intense and localized than hurricanes. They tighten their spirals up very tight so they can exceed the winds that we would find in a hurricane. Rotating wind speeds can reach over 300 miles an hour. Typically, the wind speeds are greatest about 50 meters above the ground. This is due to the friction of swirling debris near the surface, which slows the rotation speed down. But you can see the debris field here near the surface of this tornado. It slows the wind speeds down, but they certainly are still very fast. As it stands, the tornadoes do the most damage because of picking up debris and smashing that debris into things as it rolls along the landscape. So it's swirling debris that is the most dangerous in a tornado. Most tornadoes rotate counterclockwise, and this is due to the fact that most storms rotate counterclockwise due to the Coriolis effect here in the northern hemisphere. And tornadoes typically travel west-southwest to east-northeast, and that's because that is the direction most supercell thunderstorms take as they traverse across the landscape. The damage path can be up to over a mile wide, and the average tornado path length is about 4 miles, but it can go much further, of course. And they can last for 10 minutes to over an hour. You see pictured here the damage path of the May 3rd, 1999 Moore, Oklahoma tornado, and you can see that that damage path was actually about a mile wide, or a little bit over a mile wide. That was an F5 tornado that occurred, and the Moore, Oklahoma is a suburb right there near Oklahoma City. It's pictured in the green here in this diagram here. The green swath is the May 3rd, 1999 tornado. You can see there is also another tornado on May 8th of 2003, and another one in May of 2013 that went through this area. About 70% of Earth's tornadoes occur in the central U.S., as I mentioned earlier. We call this place Tornado Alley then. You can see that there's a maximum here of tornadoes at northern Texas through the center of Oklahoma and into southern Kansas. That is the most you see the most average tornadoes on yearly there. And that is because of the conditions necessary for tornadoes. And we'll talk more about that in a second. But you can see also through the central part of the United States, there's just tornadoes everywhere. And then, of course, in the peninsula of Florida, we learned that local convection makes thunderstorm activity very frequent there, and it's likely that tornadoes will form in there as well. If we look at our area, specifically, the peak tornado season for Chicagoland and northern Illinois is early June. This was a study done from 2003, and it notes that Chicagoland, Geneva, everywhere in northern Illinois, early June. If you go a little bit further south, it's late May, which stands to reason. It's a little warmer earlier down there, and a little warmer later in the northern parts above us in places like northern Iowa, southern Wisconsin. It's late June. So let's talk how tornadoes form. How tornadoes form is essentially how a large supercell thunderstorm forms, and this is when a rotating updraft, which we call a mesocyclone, and you can see that pictured in this picture here. The mesocyclone is this rotating updraft of air as it swirls upward. You can see the Coriolis effect causes the swirl, and because of the upper level winds streaming along actually pull up on air and draw air upward. So that mesocyclone and the swirling winds of the mesocyclone tighten into a tighter spiral, and at the surface they form that tornado. So again, it's the updraft, the spinning updraft, and the updraft spins due to the Coriolis effect. Upper level winds help draw air upward, tightening that spiral and causing that tornado form in this well-organized supercell. We note that those upper level winds also throw all the rain and precipitation forward. So all the downdrafts that occur because of the evaporating rain and the cool temperatures, those downdrafts actually are called the forward flank downdraft. And all the rain and hail and so forth goes forward in the storm, and that leaves a clear path for warm, moist air to enter the storm from the rear. And so that's typically where tornadoes form. They form towards the back end of the storm. And here's a beautiful picture of a supercell, noting that it is tilted, okay, from horizontal. The upper level winds are probably tilting this storm as it goes, so the rain is falling in the forward part of the storm. That leaves for the warm, moist air to come in the updraft here to form that tornado. And this is just a beautiful picture of a supercell thunderstorm. Rotation of tornadoes can be detected in radar image. This is a Doppler radar image of a supercell thunderstorm. In fact, this is the actual image of the radar from May 3rd, 1999, from that Moore, Oklahoma F5 tornado I talked about earlier. Tornadoes typically occur towards the rear of the storm. So if you think about the last slide where that tornado was, it would be right here, and the rain gets kicked forward by the upper level winds this way. So the rain is moving and being kicked this way. And so that leaves the area where the warm, moist air is entering the storm to be free of any kind of interference. And so you get this nice sustained updraft, and you have it forms a hook here. It forms a hook because of the strong rotation here that ensues. And the tornado then is usually right there in the so-called inflow notch of the warm, moist air. So you got the strong rotating mesocyclone, and it usually tightens into a spiral here to form the tornado right in this zone. So scientists nowadays, and even the meteorologists at the local news agencies have really good access to Doppler radar imagery, and they can see these supercells form, and they know where the tornado forms in the supercell, and they can warn specific towns of the incoming storm, and even down to the square miles of where the tornado is and where it's going. Now, the ingredients you need for a tornado are the same for severe thunderstorms, that warm, moist air, and for us it comes from the Gulf of Mexico down here, and it wafts into the center part of our country. And then, of course, we have air coming from Canada, and the Rocky Mountains funnels it this way. The westerlies push it eastward, and they comes plowing through like this, forming your nice cold front. Okay, and so that front of cold air meeting the warm, moist air, which oftentimes wafts its way into the center part of our country. Remember our front symbols. So you got this warm, moist air sitting here. The cold air is going to come and plow it upward to form those clouds and storms. An additional element here is the jet stream. The jet stream meanders its way through the center part of the U.S., and that helps to draw air upward. And so if you got a rotating thunderstorm cooking, and you've got a jet stream rushing along in the upper levels, sucking air upward, it's going to tighten that spiral and help tornado formation. There's another element here shown, and this is called it's called warm dry air, but it forms what we call a dry line. And the dry line is an area where this warm dry air off the high plateau of Mexico comes intruding in to areas of Texas and Oklahoma. And this dry line is another sort of frontal movement. It advances forward and backwards daytime and nighttime, and as it does, it helps pop up tornado activity. So this is another element that helps form tornadoes. And here it is, and here's that. The dry line is often indicated with a little line with really tight half circles like so. Of course, you have your cold front or your warm front with the advancing warm air from the Gulf of Mexico, typically looking something like this. And you've got your cold front from the air kind of pushing its way in from Canada, okay, with those triangular or from the blue triangles there, ushering its way through. So between the cold frontal movement and the dry line, you've got plenty of lift for that warm, moist air to form those nice, strong supercells. And here's a great picture showing the moisture and resulting storms from all this frontal movement. You see the cold front pictured here. That cool air, cold air kind of coming in from behind, pushing air upward, so you get storm formation there. You've got the hot, dry air coming in from the high plateau off of Mexico, and you can see this is actually Texas right here below that, and you got the dry line here. That's going to help tornado formation, and indeed, you can see supercells popping up all along that dry line from that forcing. And then finally, of course, the source of all this is the warm, moist air that's wafting up in from the Gulf of Mexico. And this all together makes the conditions right for severe thunderstorms and then, of course, tornado formation. So when tornadoes do form, typically most tornadoes are actually weaker tornadoes. But there are strong tornadoes that form and, of course, do most of the damage. So let's talk tornado strength. Tornado strength is very much like how that strength of earthquakes we discussed earlier, which is measured by the Mercalli scale of intensity, right? The damage done by an earthquake. Tornadoes are measured in strength by the damage they cause. And so the damage caused by the tornadoes is called the intensity of the tornado, and that measures tornado strength. And the scale used is called the Fujita scale. We'll talk about that in a second. What they do is they go out and measure damages done to residences and commercial and retail structures, schools, professional buildings, metal structures, towers and poles, vegetation. And depending on the amount of damage, they'll quantify that damage and assign it an intensity rating. And the intensity rating they assigned it on is the Fujita scale of intensity. And it's F0 through F5 based on the damage done. Using the damage done, they estimate the wind speeds of the tornado and then give it a Fujita scale rating. F0 begin at 65 miles an hour. If your winds are 65 miles an hour swirling, we call that an F0 tornado. And it goes all the way up to over 200 miles an hour sustained winds in the swirling motion as the F5 tornado. Now, this scale was created by Theodore Fujita out of the University of Chicago. He was a famous storm researcher who actually, he was the one that developed the warning detection system for downdrafts or microbursts around airports, which has saved lots of lives because airplanes just avoid landing and taking off during the time they know a microburst is imminent. And he developed that warning system back in the early 90s, but a very important researcher that helped advance our knowledge of tornadoes, which is why the tornado scale is named after him. Now it says here EF that in 2011 the Fujita scale was an quote unquote enhanced because they had to change it a little bit based on the changing construction of things. Excuse me. And so that's why you see EF there, but you can see the wind speeds listed here and then the expected damages done by each. We note that about 79, almost 80% of tornadoes are EF0 or EF1 tornadoes. So even though those are the most frequent tornadoes, they really don't do a lot of damage. Only 1% of tornadoes are EF4 and EF5, and those actually account for the majority of the damage caused by tornadoes. So even though they represent only 1% of tornadoes. So tornadoes actually do occur in outbreaks sometimes. An tornado outbreak is where multiple tornadoes occur within a short amount of time. Typically, they make a time limit of about 6 hours. If there's no more than 6 hours between tornadoes, they're considered part of the same system of tornadoes and can be called an outbreak if it gets bad. For many years, the super outbreak of 1974 was the most intense outbreak on record. From April 3rd to 4th of 1974, there were 147 tornadoes over the course of 16 hours. It occurred over 13 states. There were 6 F5 tornadoes, and there were 319 people killed. And you can see here the paths of the tornadoes indicated by these lines. showing the dark lines where the big tornadoes. There's a big EF5 tornado that rocked through Mississippi and Alabama here. So pretty crazy. Another EF4 just south of it. So that was really, really intense. That was the record until 2011. And in 2011, we have what's called the super outbreak of 2011, originally enough. From April 25th to 28th of 2011, there were 360 tornadoes over the course of over 43 hours. In 21 states, there were 4 F5 tornadoes. Again, you can see the F5s there in red. You can see there's a very large one that went across the northern part of Alabama. It killed 324 people. So this was a terrible outbreak of tornadoes. There were 4 F5s in that one. So this is a tornado outbreak. How can we stay safe from tornadoes? Well, when the ingredients for a strong thunderstorm, supercell thunderstorms, and tornadoes are there, scientists will issue a tornado watch. And it's the National Weather Service office that issues the tornado watch. Typically, scientists, meteorologists are assigned to a National Weather Service station that oversees an area. The one for Northern Illinois and all of Chicagoland is Romeoville. And so the researchers and meteorologists there issue these tornado watches if they see these ingredients present: the warm, moist air, the cold front, or a dry line, that kind of thing. Jet stream is oriented just right to help draw air upward. And then what they'll do is, if they actually observe a tornado by a trained spotter, and of course there's actually tornado spotting training schools. It's called Skywarn, where you could actually go, anybody can actually go in and become a trained spotter by taking this little course. Typically, law enforcement and public service workers such as them are trained spotters, so that if they do see a tornado, they can call it into the National Weather Service office, and it's not just some weirdo calling them. They're actually a trained spotter, and they have a identification number and the whole 9 yards to alert the meteorologist that the tornado is on the ground, right? When that happens, when a tornado is observed on the ground, they can issue a tornado warning. Another way they actually issue a tornado warning is if rotation is detected on Doppler radar. Doppler radar is getting more advanced, and it can actually see, and you can see in the upper right here, this is a picture of what a supercell carrying a tornado would look like. And what they'll see is not only the rain, but they actually see velocities too. You can switch the Doppler radar to see velocities. And remember, the tornado occurs somewhere in this zone here. And so it's pretty easy for them to see rotation on the Doppler radar in a tornado. So if a trained spotter observes a tornado, or if rotation is detected, they'll issue a tornado warning. And then, of course, when a tornado warning is issued, they initiate the public warning system, which is the tornado sirens, your local tornado sirens, and they'll go off indicating that, hey, you better get yourself into safety and go get some information on the radio or television or your phone. And of course, the news media and particularly like the local news stations now have their own Doppler radar systems and do a pretty good job of tracking storms and really being able to tell you exactly where the storm is and where it's going, so that you are better informed. It's really important for people to have advanced warnings so they can get themselves to safety. So what should you do if a tornado is imminent? Well, go to a basement or an interior room and stay away from windows. The reason for that is that most damage from tornadoes is done because the wind speeds have picked up objects and it's swinging them around, basically buzz sawing across the landscape. So if you're below that level, you stand a way better chance of surviving. Or if you're in an interior room away from the windows, you're not going to get impaled with a piece of debris flying through the window and hitting you. Some of these debris can be swirling at 100 or 200 miles an hour, and when they hit you, it's like getting hit with a bullet. I mean, it's just really nasty. So you want to stay away from windows. If you're not in a place where you're in a shelter, maybe you're in your car, it's advised that you get out of the car. Tornadoes can pick up cars and throw them, and it's basically like getting in a car accident then, which is no fun. So you don't want to do that. Instead, get out of a car, seek a low-lying area, or shelter if one's nearby. If none is nearby, then get to a lower lying area, again underneath the buzz saw that is the tornado. Get yourself low, grab onto something so that you don't fly up into the debris with it. If you have a lower center of mass. Now, of course, you wouldn't be lying on the wet ground unless the tornado was actually like rolling over you. And obviously, you would be you hopefully have the instincts enough to and the smarts enough to survive that. If in a car, a lot of people park under highway overpasses to like avoid the downpours of rain, but that's actually a dangerous place during a tornado. Debris can get funneled through those overpasses very much quicker than normal, and can really do some damage to people inside cars as well as outside of cars. So you don't want to be anywhere near those. Of course, you just need to listen to and heed weather reports, knowing that when a watch is issued, you need to kind of like have a little bit of alert on to recognize, I'm in danger. I better get myself taken care of into safety. So that's my deal on tornadoes. I hope you learned a lot about it. Tornadoes are always interesting to talk about, and they're always very relevant because we know we have thunderstorms passing through all the time that have the ability to spur up into a tornado. So thanks for listening, and that's tornadoes.